In this video, we will practice solving trig equations such as these ones. Now, as I solve these equations, I am going to assume that you have either memorized the facts on this sheet, or at the very least, you should be able to generate this table of values within about a minute and a half. So, how do I solve this? Now, let me tell you what you can't do. You cannot divide both sides of the equation by cosine. It's very tempting to do this. Divide by cosine, skirt, cosine squared. Nope. Unfortunately, that's not allowed. All right? The reason why is because sometimes cosine has a value of 0, and you're not allowed to divide by 0, so that's invalid. Instead, we're going to subtract cosine from both sides. So that will leave us with cosine cubed x minus cosine x is equal to 0. I'm going to factor this, and the first step of factoring is to factor out a common factor. So I see that cosine is common, so if I take cosine out, that leaves me with cosine squared x minus 1. So now I'm going to use the zero product property and set each of these equal to 0 and solve. So this would be cosine x is equal to 0. That's going to give me solutions. And then on the other hand, I'm going to have cosine squared x minus 1 is equal to 0. I'm going to solve each of these. So on the left-hand side, where I have cosine equals 0, I am going to solve that by looking at quadrantal angles, like this. All right, on the unit circle, this is the point 1, 0, and this is 0, 1, and this is negative 1, 0 right here, and this is the point 0, negative 1. Now, cosine is the x value on the unit circle, so I'm looking for the angles where the x value is equal to 0. So that's 1. Here's an x value of 0. That's negative 1. Here's another x value of 0. So these are the two angles that have a cosine equal to 0. So I'm going to record those solutions, which are, so far I have x equals pi over 2, all right, here at the top. And down here, this is 3 pi over 2. Okay, now let's keep going and solve this side. So I've got these so far. Now, if I solve cosine squared x minus 1 equals 0, I'm going to add 1 to both sides, so that's going to give me cosine squared x is equal to 1. And then I would need to take the square root of both sides. Now, when you take the square root of both sides, don't forget your plus or minus. The solution can be plus or minus. So that's going to leave me with cosine x is equal to plus or minus 1. So again, let's look at the unit circle, checking out the quadrantal angles. All right, and again, we're looking for x values, but this time we want plus or minus 1. So here's an x value of 1, so that's going to be a solution. That's 0. Here's an x value of negative 1. We're also looking for that, so that'll be a solution. And then the other x value is 0 again. But both of these angles are solutions, so that will give us two additional solutions of 0 and pi. Okay, so these are the 4 solutions to the original equation. All right, now let's take a look at number 16. Now, I'm noticing that we have two different types of trig function. We have secant squared and tangent squared. We need to do a substitution so we can get all one type of function. So look at secant squared. Let's see what we can do with that. Okay, secant squared is equal to 1 plus tangent squared. All right, that's something that you should have memorized. So I should be able to make that substitution right here, right? Substituting this for 1 plus tangent squared. That is going to give me 2 times 1 plus tangent squared x, and then the rest of it, plus tangent squared x minus 3. Okay, so that is going to give me a distributive property here. That'll be 2 plus 2 tangent squared x plus tangent squared x minus 3 is equal to 0. These are like terms. 2 tangent squared plus 1 tangent squared is 3 tangent squared x. Also, 2 and negative 3 are like terms. Putting those together, I get negative 1. And all of this is equal to 0. So this will give me 3 tangent squared x is equal to 1. I'm just adding 1 to both sides. Dividing both sides by 3, I get tangent squared x is equal to 1/3. Now, taking the square root of both sides, I'm going to get tangent x is equal to plus or minus 1 over radical 3. Now, notice just now when I took the square root of both sides, I'm taking the square root of 1/3. Now, just understand that this is the same thing as square root of 1 over the square root of 3. And the square root of 1 is simply 1. So that's how I got 1 over radical 3. Don't forget your plus or minus. Okay, now the tangent of what angle is 1 over radical 3? Don't worry about the plus or minus yet. The tangent of what angle is 1 over radical 3? Okay, the tangent of pi over 6 is 1 over radical 3. So that tells us the reference angle. So that tells us that the reference angle is pi over 6. All right, so what I like to do is once I see the reference angle, I draw myself a diagram. Okay, so if the reference angle is pi over 6, I'm going to draw a diagram of pi over 6's. So far these are pi over 2. And so if I split each of these up into 3 parts, then that will be 6 parts, so pi over 6. Okay, so these are now pi over 6's. So here are the 4 angles that have a reference angle of pi over 6. The tangent of any of them will give me 1 over radical 3, but 2 of them will be positive, okay, here and here, and 2 of them will be negative, here and here. Because we want positive or negative 1 over radical 3, all 4 angles are solutions. So the solutions are x equals, so the first one is pi over 6. This one over here is 5 pi over 6. This one is 7 pi over 6. And this one is 11 pi over 6. All right, all 4 are solutions because of the plus or minus. All right, so it's really important that you not forget when you take the square root of both sides, the solution can be plus or minus. Okay, what's next? All right, let's go ahead and do number 17. All right, it's getting a little crowded in here, so I think I'm going to change colors so we can differentiate a little bit. Again, the one thing I cannot do is divide both sides by tangent. So whatever you do, don't divide by trig function. Instead, I will subtract. So that's going to give me 3 tangent cubed x minus tangent x is equal to 0. Now, a tangent is a common factor, so I'm going to factor that out. So that will give me tangent x, and then that will leave behind 3 tangent squared x minus 1 is equal to 0. Now I'm going to use my zero product property and set each of these equal to 0. So that's going to give me tangent x is equal to 0, and then 3 tangent squared x minus 1 is equal to 0. All right, solving the right-hand equation, I'm going to add 1 to both sides. So that'll be 3 tangent squared x is equal to 1. Dividing both sides by 3, that'll be tangent squared x is equal to 1/3. Taking the square root of both sides, and being careful to put plus or minus, I'm going to have tangent x is equal to plus or minus 1 over radical 3. Now, I feel like I shouldn't have to do this again because we just did tangent x is equal to plus or minus 1 over radical 3 on the previous problem, this exact same thing. So of course we're going to get the same answers again. So I'll just refer back to it again just in case you skipped to this part of the video. We know that tangent of pi over 6 is 1 over radical 3. That told us that the reference angle was pi over 6, so we drew a diagram of pi over 6's. We had 4 angles that have a reference angle of pi over 6, shown here in pink, 2 positive, 2 negative. Because it's plus or minus, all 4 of them will be solutions. And these are the 4 angles illustrated below. So I'm just going to copy this list over again. Okay, so over here we will have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now that's not the end because we also have this. Tangent of x is equal to 0. So we need to explore that as well. Okay, but that's going to be a quadrantal angle though. So let's explore that by making a unit circle showing the quadrantal angles. All right, so let's look at these extreme points. So this is going to be 1, 0, and 0, 1, and negative 1, 0, and 0, negative 1. Okay, tangent is y over x. So the tangent up here is going to be 1 over 0. The tangent here will be 0 over 1. The tangent on the left side will be 0 over negative 1. And the tangent here at the bottom is going to be negative 1 over 0. Okay, now look. You can't divide by 0. So this is undefined and this is undefined. Now we want the tangent to equal 0. So that's what's going to happen here. All right, 0 divided by 1 is 0. 0 divided by negative 1 is also 0. That's why both of these are solutions. So in addition to the list that we already have, we have 0, angle 0, and pi. So I'm just going to add those to my list. So now I have x equals 0 and pi in addition to the rest. Okay, so this is the complete list of solutions. Okay, take a look at number 18. We have sine and cosine, so I really want all one type. Sine squared x, let's remember our Pythagorean identities. Sine squared is equal to 1 minus cosine squared. So let's make that substitution. So this will become 1 minus cosine squared, and then the rest of it. Okay, now let's get 0 on one side by subtracting 2 from both sides. Now I'm going to rewrite this in descending exponential order. So I'm going to put my negative cosine squared first, and then followed by plus 2 cosine x. And now 1 minus 2, of course, is negative 1, but I'm going to put that at the end. And that equals 0. Now I would like to factor this, but I'm more comfortable factoring if I have a positive leading coefficient. So I'm just going to divide everything by negative 1. So that will give me cosine squared x minus, whoops, yeah, let me erase. So minus 2 cosine x plus 1. Just changes all the signs. Equal to 0. Now I can factor. So this should factor as a binomial times a binomial. Cosine squared x can only factor as cosine x times cosine x. 1 can only factor as 1 times 1. Inner plus outer equals middle. So inner, I have 1 cosine x. Outer, I also have 1 cosine x. The middle is negative 2 cosine x. That will happen if both of these are negative. So that would mean both of these are negative. That works because negative 1 times negative 1 is positive 1. So there we have factored it. So now I can use the zero product property and set each of these equal to 0. Since they are the same, I don't have to do it twice. I will just take one of them and set it equal to 0. So that is going to give me cosine x is equal to 1. So this is going to be a quadrantal angle for my solutions. Okay, so here I have 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Cosine is an x value on the unit circle. So we want the x value to equal 1. So I see that the x value equals 1 right here and nowhere else. So that's why the one and only answer is x equals angle 0. All right, for this one, we have all secant, so I think I'm just going to leave it like this. I'm just going to subtract 2 from both sides, so that's going to give me secant squared x minus secant x minus 2 is equal to 0. This should be factorable. So secant squared will only factor as secant times secant. 2 can only factor as 2 times 1. Inner plus outer must equal middle. Inner, I have 2 secant x. Outer, I have 1 secant x. I'm trying to get a middle of negative 1 secant x. That will happen if I have a negative and a positive. So there's my negative 2, and here's my positive 1. That makes sense because negative 2 times positive 1 does give me negative 2, so this is correct. Now I can use my zero product property and set each factor equal to 0. So secant x minus 2 will equal 0, or secant x plus 1 could equal 0. This will give me secant x is equal to 2, and this side will give me secant x is equal to negative 1. Now secant is the reciprocal of cosine. So imagine doing the reciprocal to both sides. So the reciprocal of secant is cosine. The reciprocal of 2 is 1/2. The reciprocal of secant is cosine. The reciprocal of -1 is still -1. Okay, so now let's solve these two equations. Looking at the 1/2, what is the reference angle? Cosine of what angle is 1/2? Well, cosine of pi over 3 is 1/2. So that tells me that the reference angle is pi over 3. Okay, so let's draw a little diagram of pi over 3. Okay, so these are the four angles that have a reference angle of pi over 3. The cosine of any of them will be some kind of 1/2, but these two angles will be positive, while these two angles will be negative 1/2. We want positive 1/2, so that tells us that the solutions will be here and here. So that gives us x is equal to pi over 3 and 5 pi over 3. Meanwhile, what about this? Cosine x is equal to -1. All right, so here we have 1, 0, 0, 1, -1, 0, and 0, -1. Cosine is the x value, so we're looking for the places where the x value is -1. There it is. This is the only place where the x value is -1. That's pi. So we'll add one more solution of pi. So these are the three solutions to this problem. All right, one more problem. This one has all cosines, so this should be pretty easy. Subtracting 1 from both sides will give us 2 cosine squared x minus cosine x minus 1 is equal to 0. So let's go ahead and try to factor it. 2 cosine squared x can only factor as 2 cosine x times cosine x. 1 can only factor as 1 times 1. Now inner plus outer must equal the middle. Inner, I have 1 cosine x. Outer, I have 2 cosine x. I'm trying to get a middle of -1 cosine x. That will happen if I have a +1 and a -2 cosine x. So there's my +1 right here, and a negative here will give me the -2. Also, +1 times -1 is -1, so it works. Next, we will use the zero product property to set each one of these factors equal to 0. So 2 cosine x plus 1 is equal to 0, and cosine x minus 1 is equal to 0. 2 cosine x is equal to -1, subtracting 1. Dividing both sides by 2, I have cosine x is equal to -1/2. Adding 1 to both sides, I have cosine x is equal to 1. All right, now let's do our analysis. Okay, looking at the cosine x equals -1/2, the reference angle for that guy is pi over 3. Okay, because the cosine of pi over 3 is 1/2. So if we have a reference angle of pi over 3, then this is the diagram that I will draw. Okay, these are pi over 3's. There are 4 angles with a reference angle of pi over 3. Here, 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 and here. In this case, we want a negative cosine. So we're going to want these two angles over here, because cosine is positive on the right and negative on the left. We want the negative ones. So the answers will be here and here. So that's going to be 2 pi over 3 and 4 pi over 3. All right, in addition to that, we are going to solve the equation cosine x is equal to 1. All right, for that, we will look at the quadrantal angles, which go like this: 1, 0, 0, 1, negative 1, 0, and 0, -1. Cosine is the x value, so we're looking for an x value of 1, and you will find that here and nowhere else. So that's why this is the solution. 0, angle 0. So in addition to these two, I will add 0 to the solution set. All right, that's going to do it for this video. I hope it was helpful, and I look forward to seeing you on the next video.